Australia. Michelle will be presenting on automatic map deconstruction using QGIS. Welcome, Michelle.
Thank you guys for coming on this second talk of the session. For those people who don't know where I'm from Perth, which is the west coast of Australia. And I mainly work with geologists and geophysicists, the whole of geoscience people. So is there any geologists, geophysicists? Okay, at least we have someone that will understand the language. So that means I have to rebrand my whole talk so that the audience capture what I'm trying to convey here. But the good news is we'll try to make it more like QGIS focused than geology and geophysics. Well, thank you for the opportunity to share this again at the FOSS4G this year. It's basically trying to use some of the algorithms that exist in the field of geophysics and geology to make better 3D modeling for Earth subsurface exploration. As you know, we all rely heavily for mineral resources, and some of these very talented researchers out there publish a lot of good stuff there, but unfortunately, some of those algorithms usually stay within the research papers. And one way to kind of increase the usability of this project is to kind of publish it in a framework where anyone can access it and then use it, maybe test it on their own problem. So two things, we have Map2Loop, which is one engine, and then we have LoopStructural, second engine. The difference between the two is Map2Loop is the engine that if you go from a 2D map, you can extract more details. When I mean maps here is like geologists, when they go into the field, they collect data point. They look at lines which are fault, for example, and in the past they used to draw it on papers. Nowadays, with the beautiful Q field, they can actually do it in a mobile phone. So that's the advantage of collecting data on the point. So what we're trying to do here, we're trying to basically connect all of that from capture those data, and then sitting on your desk, even in a campsite, you'll be able to generate a 3D models while you're doing your acquisition, and then have maybe a second thought how to collect the next set of your samples in the field. And then it goes on iteratively, the way you want to do it. So I will just give you a little bit of overview of this in-house QGIS plugin we developed. It goes from field data acquisitions and 3D modeling and even pre-processing some of the data as a geologist. Because you may have heard that geologists tend to fight against geophysicists because the interpretation from the geophysicist's point of view might be different to the geologist's point of view. So we're trying to convey into the same band now so that if they can understand what the language is on that end, then that makes a perfect resolution for all of us. So before showing you exactly why you're here for, I thought maybe I should share some of the plugins we've developed in. So I actually divide it into two categories. One is just for processing, and then the second one will be one doing some inversion in the geophysics space. So the first one is what we call the GeoQMaps tools. So this tool basically, as you all will agree with me that if you collect data in Mongolia, you will have a different tabular notation. Same thing in Australia and in France, for example, they will use French. So the game here is to try to collate everything in a way that how do we synchronize all those data so that if I'm sitting in Mongolia or in Australia, to use the same kind of symbology and then also the heading, you kind of field map it. So in this case, we're doing using an algorithm called fuzzy text matching so that when you load your data, it kind of correlates what exists on the system. And then if you see it's green, that means they're kind of matching, then you can save it. So at the end of the day, you will recreate the same data set with, let's say, optimized data, which is formatted in the standard way that anyone can actually use without trying to change anything on that data set. It's available as well, publicly available on our GitHub repository. This one is even available on a QGIS repository. The second one is, this is called the SG tool. It stands for Structural Geophysics Tool plugin. And this plugin actually was developed in regard to people like in Africa who don't have the means of buying softwares. And my boss basically designed this plugin for his course lecture when he goes in Africa for some non-profit organizations that he built for himself. So it's basically use the data, geophysical data, to do the pre-processing that you probably will do in the commercial software. So this is pretty much, he's applying some filtering technique on a geophysical grid to basically try to delineate some of these features. And you can see it's easier. You can sit on a table in a restaurant and then just processing. It's very easy. So more or less, you don't need to be a geophysicist to do that. You read the documentation. If you have a similar image, you can apply all these techniques as well. And it's publicly available and publicly in QGIS repository as well. And this, for example, have drawn a lot of attention lately. We actually had like 3 users, but since it was published, we have about 10,000 downloads, which is the power of having open source, because that's where we want to go. We want to have a better world, and if we want to deal with things like climate change or greener future, we need to have these kind of things exposed. The advantage of having this one, it helps geophysicists interpret better, and also in the interpretation of them looking for where next we have to drill, this might actually impact the number of drill holes within that terrain. So the fact that we're going toward that direction is quite great. And the second one is this one. This is a colleague of mine, Vitaly Ogarko. He's the one who built this module. Tomofast is very popular in the exploration geophysics space. So basically, if you know you have gravity data or magnitude data, you can actually use this free open source, and we even have the plugin for it in QGIS, published in QGIS as well. And I'm working on building an agentic workflow to kind of have a chatbot where you don't need to actually push buttons, but it's going to be chatting with something and then do your 3D modeling from start to the end. So, and at the moment, in this video, we do the visualization in the 3D model visualization in using ParaView, which is one of the free open source as well for 3D modeling. But we actually still excited to wait where the 3D visualizer, the core 3D visualizer of QGIS comes. So that's something we're working on. But in the meantime as well, we're using PyVista, which is a module of Python that you can actually do 3D modeling, which you can even embed in the Qt feature within your plugin. So we have that as well. But in this demo, it's more or less just ParaView, and he actually enjoys using ParaView himself. So, and we know that companies don't like to install free stuff on their computers, but luckily we have most of the Windows computer comes with WSL now, so we are kind of push it into running it in your local machine, but using Windows subsystem Linux, and it's very easy to do. You can see here, this is the density. From the gravity data, you can generate a 3D model of your density within your area of interest. And it's very fast now with the advent of computer with nice graphics. So this model, you can run it maybe in 1 minute, very quickly. So you don't need to have a very, very fancy GPU or system. It's quite good to run. So this can give you an indication. For example, if you're going into a terrain, you can see the highs and the lows. You can actually decide to go pick up a few samples near the highest area there, then see what people in the lab can tell you about the rocks picked up in that space. Then the second part here is basically looking at the map deconstruction. So what we do, we feel like as geologists, we know that especially in Auckland, we have a lot of volcanic system here, and those are deeper. How do we map all of that in the vertical directions? So we know that with this engine, we can actually generate, let's say, the line. You pick your line, you pick some point where the fault contact each other. You may have a fault system, and with that, we generated that map loop algorithm, it is basically just a processing engine that if you suck in some data, if you suck in, for example, over here, the geology polygon, the fault line, structure point, the DTM, this is very similar to like doing data acquisition in the city. Similar to roads, those are your fault. Structure point might be you will decide to pick up the number of street light. Those are your point. And then the DTM is the digital terrain model, and the polygon might be some of the council polygon. And then if you actually suck it into the map to loop engine, it actually generates multiple, it augments your data. So it gives you more detailed data set that you can use for different purposes. We have, for example, UK Geological Survey using this data for city planning, because if you know where the fault actually contact each other, then, for example, when you're living in a very volcanic or seismic place, you can actually ask yourself question, is it the best place to plan a city? So they're using it as an application for this part only. But some people who are very interested in machine learning, this is a better use case for your data. You need more data, and we know that all models, when you get more data, they perform better. So you can use even this as augmented data to kind of better train your model. Some of the advantage of this algorithm is it will generate for you some what we call a network graph. The network graph here is basically, it does give you kind of the relation between the formations you have, the groups, and the fault. And this is stacked in the temporal way, so that we know that the oldest event during creation started below, and then they kind of stack by the younger toward older generation. And it's very good because a lot of engine that does structural modeling in, let's say, in the geoscience space, don't use this fact very often during their modeling strategies, because it's very tough to estimate the time, the age of the structural stratigraphic unit you're dealing with. So basically, we have this loop, the libraries that we're dealing to have everything ongoing. So this is just, if you run map to loop, it will generate like one file for you which capture all the information that you've seen on those different detail maps. And then this is just an example in the middle, one of the data it will capture, stratigraphic thickness estimate. And then from these input, you can go in the LoopStructural where you do your modeling to generate 3D model. And because we know that every model is wrong, then we have the possibility to generate multiple model and then do the uncertainty quantification. That's another plugin. We haven't released it yet, but the publication is out there. You can use the paper and then rebrand it. And then we do that until we have the best optimized model. So that's the core structure of map to loop. And then in general, we want to go from 2D map, we put it in our engine, and then it develop this multiple data set. And remember, I have this, I've shown you this plugin that does automatic, that use fuzzy logic, can actually even be used here to kind of rechange things in your data set, and then go into modeling here, 3D modeling. Then with the new advent, you can actually even extract the loop meshing, because the mesh is very important for people doing modeling, and the application has been now done into hydrogeology, for example, for people looking for flow transport. And this is just for doing resource modeling. And you can go back again and again until you're happy about your system. This is just an example of what has been done so far. You can see we've tested few models along Australia. This is WA at the Hamsley Basin, South Australia. So to tell you that you can do, but on a regional scale. So we've been testing some few cases for like a mine site scale now. And to wrap up, this is the plugin. So basically, is it not running yet? Okay. Need to click there. Yeah. So that's how it looks like. Then at the end here, this is the 3D visualization model. You can see that's your layers. So you can load layers from your local file, or if you already have an existing layers available in your QGIS, then you can access it directly from the plugin. And then the first part is just pre-processing the data from geology, fault, and the structure point. Then that push button here is more or less just to run your calculation, which is the modeling part. And you have the option either to do it for the server, from your own server, or you can use external server as well. And we have that one option where we can pull out the data from the GeoSense Australia. For example, the digital terrain model, if we don't know, we have a push button there, then you actually give it like the bounding box, then it will generate a DTM for you, which you will use internally. And then at the end, you have the choice. You can even visualize. So if you run this one, will generate the VTK format. And then if you click 3D plot, it will generate something for you for now. And this is just for someone who has the data. But for someone who actually want to do research, we have another version of the same plugin. But this one, we're dealing with like multiple data sets. So assuming you don't have all these 4 layers, it does not prevent you to run a test model. So this is what we're doing here. And this is more or less used for research purpose if you want to do it, because you can select only few layers, and then it will generate as well the model for you. And this one, I might be wrong, but should be publicly available now in QGIS. This is work done from a colleague of mine who's from Monash University, Lackland. And this is just selecting how you want to stack your stratigraphic unit if you know the time. So I probably will leave it there. Otherwise, the resources we've got for you basically available here. So I have 3 categories. This is for building 3D or extracting digital data. This is for field mapping. And then the geophysical tool is this one for processing, and this one is for the microgravity inversions. There are quite a lot of work has been done for this. And I think I should stop there. Thank you for your attention.
Thank you very much. Now I invite any questions. So sorry, Bex.
Thank you, that was really awesome. How are you feeling about your inversions? They look pretty amazing.
Which one, the structural one or the gravity one?
I guess, have you got anywhere you want to go next with them?
Well, because we're living in a very moving, fast area, so the next step is me being exposed with Google technology, and I'm trying to work on more or less applying all of this in the LLM side of things, so that we can embed like a chat bot in this QGIS front end, for example, so that you don't need to actually click all these buttons, you can just communicate with it. So that's the area I'm actually looking at. And we already have something as a draft paper, which is probably next year by mid-March, we probably will have it released. Yeah.
Thank you, Michelle. On your last slide, you had some information about the field mapping tool. I was just going to ask you if you can just elaborate a bit more on what are the use cases, like what are the kinds of steps? Is it like a QGIS plugin or QField plugin, or is it a separate?
Well,
Can you elaborate?
I can explain to that. I didn't present that. We have two field mapping tools. So the beauty with open source, QField exists, and we have built our own tool that generate project that you can suck into field map, QField, and then collect your data point. So we use QField, but the project is labeled because you see let's say the headers, things that you want for your project is not what QField gives you. But I've seen the new release might be very similar to what we already built. So if that's the case, then we probably want to be using our own customized one. But we use QField for that particular template that we generate that goes into QField, and then you do your mapping as everyone. If you want to pick point, for example, we pick up stratigraphic unit or whatever, we do it as well. And then you export the result I will do probably for a different project in city planning for QField. So we have something like that. The one I showed here, it's basically one way to harmonize our data, because we know the data in different places may have different column headers and stuff like that. How do you harmonize it so that it becomes standard, so that we're talking about fair here, reproducibility, repeatability. So these are the path we're taking, so that in the longer term, that's going to be a whole topic. But we're starting on the first step here. So we have it, and I didn't share the link for that one, but if you want, I can show you as well, or give you the link. It's publicly available on GitHub, on QGIS as well, or the one that you attach to QField. No, main QGIS repository, it is there, and in our repository as well. Yeah.
Any final questions? Okay. Let's give a big thanks to Michelle.
Thank you.